G'day Year 7s, long time no see, or long time no speak is probably a little bit more appropriate. Welcome back to our video series of tutorials looking at our various units of maths. Okay, this is one of our last units we're going to do, obviously, getting very close to the end of the year. We are doing here Introduction to Equations. This is going back to algebra stuff, and we have done a bit of algebra stuff, so you're going to have to remember some of that stuff, because remembering that will help you here. Okay, first little point, don't have to write any of this stuff down because the next slide, they're the notes you need to take. So very quickly, an equation is a mathematical statement used to say that two expressions are equal. It will always consist of two expressions, and we've talked about what expressions are, okay, which can be numbers, could be letters, could be a combination of numbers and letters that are separated by an equal sign. So sample equations include, so this is a sample equation, so 3 plus 3 equals 6, okay. 2 times 15 equals 30. 100 take 30 equals 70. Could add anything else. 50 divided by 2 equals 25. They're all equations. All right. So provided you've got a left and an equal sign and a left and right, you call it an equation. Now all these equations we say are true. Okay, because 3 plus 3 equals 6. So this side equals, this side equals this side. 2 times 15 is 30. So this side equals this side because it says 30. This is 70 on this side. 100 take 30 equals 70. So they are true because one side equals the other side. They are the same. Alright, an equation does not have to be true though. You can have an equation that is not true. Alright, so for instance here we have on this side 17, and then we have 2 plus 2 equals 4. Okay, so this is not true. Alright, and you can see the other examples there. I'm not going to go through them all. Alright, so the first couple of things is that you have a left and a right side. So a left side of the equation, and then the equal side, and the right side of the equation. Okay, and for it to be true, both left and right sides will equal. For it not to be true, the left and right sides won't be equal, though you'll get different results. Alright, so they are all false equations, these ones at the bottom here. Now, at the bottom here, last little note, if an equation contains variables, one cannot tell whether the equation is true. So you can't, if it's got a variable, you don't know whether it's true until the values of the variables are known. Okay, so for example, 5 plus x equals 7. Alright, this would be true if x was 2. So if x equaled 2, it would be 5 plus 2, which equals 7. Okay, so 5 plus 2 is 7 there, that's 7 there, so that would be true. But if x equals 15, for example, so you'd end up with 5 plus 15, poor 15, equals 7, that would be not true, that would be false, because 5 plus 15 is 20, that does not equal 7. Okay, so that would be false in that case. Alright, so basically as a summary, so these are the notes you need to make sure you have written up in your book. So an equation is a mathematical statement stating that two things are equal. So a left side, so equations have a left-hand side of an equal sign and a right-hand side of an equal sign. Okay, so you've got to get that right in your head to begin with, because understanding that the equal sign separates your equations up into a left and a right makes it much easier down the track. Okay, so equations have a left-hand side and a right-hand side, and an equal side is sitting in the middle there. Equations and mathematical statements can be true or they can be false. Okay. True if both sides are the same, so 2 plus 3 equals 5, and 5 on that side, so they are true, or false if they do not. So 5 plus 7 is 12, on the right hand side is 21, so that is not true, that is false. If a variable or pronumeral, remember the pronumerals, that's what the letters are called, is included in your equation, you need to know its value to decide whether the equation is true. Okay, and we just did that on that last example, showing you that one. Alright, so you need to know the value of the pronumeral to decide whether it is true or false. Let's do some examples. So which of the following are equations? So what do you look for when you decide whether it's going to be an equation or not? Well, it's got to have an equal sign, it's got to have a left side and a right side. Equal sign, left side, right side. True, that is an equation. Not after whether it's true or false at this point, you're just stating whether it's an equation or not. We've got an equal sign, we've got a left side and a right side, so that is also an equation. Here we've got 2 plus 12, we don't have an equal sign and we don't have any other sides, so that is not an equation. 4 equals 12 minus x, Well, just because it looks like the equation's been flipped around a little bit, we've got an equal sign, we've also got a left side, and we've got a right side. So that is still an equation. So provided it's got an equal sign, something on the left of it, something on the right of it, it is an equation. 3 plus u, there's no equal sign, so there's no left or right sides, so that is not an equation. Okay, hope that makes sense. Next one, for each of the following equations, state whether it is true or false. Okay, so this one, 7 plus 5, 7 plus 5 is 12, and the right side is 12, so that one is true. B, we've got to work both sides out here, so 2 times 4 is 8, so that is 8 on that side. 5 plus 3 is also 8, so that is true because this side is the same as this side. Okay, ends up with the same value. Here, a bit of working out to do. 14 plus 5 is 19. This one, a bit of BIDMAS needed. I've got to do the brackets first. So 2 minus 1 is 1. So you end up with 12 times 1, which equals 12. 12 on the left side, 19 on the right side. That one is false. Sorry, I need to write true on there. D. Alright, so we've got a pronumeral here, so we need to substitute. We're given a value, x equals 7. Alright, so I'll do some working out down here. So 3 plus 9. Now what goes between the 9 and the x? Can you remember what is happening when you see a number and a letter or a pronumeral side by side? Hopefully you said, well, I remember that, Mr. O'Donnell. We did that in class because you're such a great teacher. You taught us really well. That is 9 times x. Okay, now I'm going to get rid of that x because it's no longer 9 times x because we're being told that x is 7. So it's actually 9 times 7. Okay, equals 60 plus 6. Alright, so I've got to substitute that value in first. Then we can work this stuff out. So 60 plus 6 gives us 66. BIDMAS here, I've got to do my multiplication before any addition. So 9 times 7 is 63. So 3 plus 63. 3 plus 63 is 66. And this side is also 66. So this equation is also true. Okay, now I'm just going to get rid of all that stuff. Hopefully that made sense to you, just so I've got a bit of working out room because I probably will need it. Sorry, just bear with me. Alright, so we know that one is now true. Okay, 10 plus b equals 3 plus b, 3b plus 1. So b equals 4, so we've got to substitute this in. So 10 plus 4 equals 3, remember there's a times happening between there, 3 times 4, it's no longer b, we're told what b is 4, so instead of b we write 4, plus 1. Okay, 10 plus 4, nice and easy, 14, got to do BIDMAS here, so now look at all these different mathematical things that we've learnt this year all coming together in this one unit. 3 times 4 is 12, plus 1, so 14 stays on that side, 12 plus 1 is 13. These guys do not equal, left and right do not equal, so that is false, that one. And last one here, so x equals 5 and y equals 8, so 3 plus 2x equals 21 minus y, so the x value has to go in here, so it's now 3, so I'm looking at this left side of the equation, 3 plus, instead of 2 times x, it's now 2 times 5, equals, so that equals is putting in there. Now I've got 21 minus y, and y is 8. So now I can work this out. 2 times 5 is 10, so 3 plus 10. 21 minus 8, I believe, should give you 13. 3 plus 10 is 13. This stays as 13 on this side, just drops down, 13 and 13. So this one is true. Alright, hopefully that makes sense to you. So you've learnt so far deciding what are equations or what are not. So equations have an equal sign and something on the left and something on the right. You then work out whether they are true or false. True being both left and right sides will be equal. False is left and right sides will not be equal. And our last little one here, and you've done these a little bit, for write equations for each of the following scenarios. Okay, so you've got to write equations for each of these. So you've done this in your last unit. So it's, for example, the very first one, the sum of x and 5 is 22. So what does sum mean? That means you are adding. So the sum of x and 5, so a here, x plus 5 is 22. So the sum of x and 5 must equal 22. And that's all you've got to do for that one. All right, really easy. B. The number of cards in a deck is x. In 7 decks there are 91 cards. Okay, so we don't know how many cards are in a deck, So it must be, if there are 7 decks, so it must be 7 decks multiplied by the number of cards we have, and the number of cards we have in each deck is X, so we don't know what it is. And in total there are 91 cards. So that equals that. So to make that completely correct, we don't write it as 7 times X, remember? Like when we were looking at these, 9X, that's 9 times X, but we don't write it with the multiplication, we just write the number and the letter. So this is no different. So this one should be written as 7X, oops, missed my 1, equals 91. Okay. C. Priya's age is currently J. In 5 years' time, her age will equal 17. Okay, so her age at the moment is J. 5 years' time, it's going to equal 17. So whatever her age is now, we need to add 5 years onto that one, which will then equal 17. Alright, so it's J plus 5 equals 17. And our last one, which is a little bit more complicated, Corey earns W dollars per year. He spends 1/12 of that on sport and 2/13 on food. The total amount Corey spends on sport and food is around $15,000. So we know all that must equal 15. So whatever he spends on sport and whatever he spends on food equals $15,000. Okay, so our 15,000 goes in there. He earns W per year, so 1/12 of that on sport. So you've got to have, what are we, 1/12, oops, 1/12 multiplied by W. Okay, so whatever he earns for the year, 1/12 of that goes on sport, and then 2/3 also go on food. Okay, so it's basically the same thing. So you've got 2/3, whoops, let's redo that one again. 2/3 multiplied by W. So 2/3 of that, whatever he earns per year, is spent on food. Now we've got, this isn't an equation yet because we're missing something. So what do we have to put in between his sport and his food? What do you think goes in here? He spends 1/12 on sport and 2/13 on food. So all that in total then equals $15,000. So hopefully you said, well, we've got to add those two totals together. Okay, so it's 1/12 of W plus 2/3 of W should equal $15,000. Okay, that one's a little bit more tricky. Okay, for those that are understanding all this, they're the type of questions you need to be able to understand. For those that are probably struggling with this a little bit, it's probably the first 3 type of questions you want to try and get to and make sure you understand them. Alright, that is all. That gets you started. So do please make sure you watch this. A bit late saying it now when it's already finished, but thank you for watching. Good luck, and that'll get you started on exercise 10A. Thank you guys. See you next time. Bye bye.